हाय यस हम लोग एक अजीब दिन पे आज लाइव हैं ऑन फ्राइडे इंस्टेड ऑफ थर्सडेज आई नो दिस इज हैप्पी फ्राइडे नाउ दिस इज द सेकंड लास्ट लेक्चर दैट आई एम गोइंग टू बी डूइंग ऑन इलेक्ट्रोकेमिस्ट्री मैंने आपको बताया था कि बैटरीज वाला पार्ट इज समथिंग दैट यू आर बेटर ऑफ स्टडीइंग फ्रॉम एनसीईआरटी डायरेक्टली उसके लिए ज्यादा कुछ करने की जरूरत नहीं है बट इफ यू हैव डाउट्स इन दैट come feel free to ping me on Discord or on Telegram about it. आज we're going to cover the basics of conductivity of solutions. NCERT में कहाँ पे? I'll show you right away. In the next session, which is tomorrow, we will look at क्या देखेंगे? Oh, we'll do Kohlrausch law. We'll do all of that. Weak electrolytes, strong electrolytes, etc., and molar conductivity क्या चीज होती है? So today, a couple of questions जो electrolysis के थे, एक homework question, एक और very interesting question about coating, some sort of a layer on top of very thin layer, जिस पे सवाल कभी-कभी आते हैं JEE में और NEET में. After that, we will do this. So, shall we just open up NCERT? मेरी आवाज आ रही? Can you hear me and see me clearly? Give me that thumbs up very quickly over here if that's okay. Yeah. So hold on. This is the NCERT. No, this is not the NCERT. This should be the NCERT. Here you go. All right. This is the NCERT, right? मेरे सर के exactly ऊपर. NCERT में 3-4 pages होंगे approximately that we're going to do. Conductance of electrolytic solutions. This is the focus of today's session, right? इसमें काफी पैरेलल्स होंगे फिजिक्स के साथ सो आई होप योर करंट इलेक्ट्रिसिटी इज काइंड ऑफ ओके बहुत बेसिक्स एक्चुअली इवन 10th स्टैंडर्ड फिजिक्स इज गुड इनफ फॉर दिस टू बी ऑनेस्ट आई थिंक 10th स्टैंडर्ड फिजिक्स शुड बी इनफ टू अंडरस्टैंड दीस आइडियाज हम लोग थोड़ा सा हॉप्स के ऊपर जंप करेंगे बिकॉज फिजिक्स में यू टॉक अबाउट कंडक्टर्स दैट आर वायर्स और इलेक्ट्रॉन्स मूव थ्रू वायर्स यहाँ पे हम लोग कंडक्टिंग सोल्यूशन पूरा पूरा सोल्यूशन ही कंडक्टिंग है और उसके थ्रू आयन मूव करेंगे दैट विल लीड टू वेल करंट ओके हम लोग उसकी बात करेंगे द पॉइंट ऑफ व्यू विल चेंज but the idea mathematical treatment similar होगा physics से we'll do all of this that's here ठीक है rho equal to r equal to rho l by a we'll invert that we'll write g equal to kappa a by l और l by a is still going to be the same is going to be equal to g star which is cell constant ये चीजें सेम है maybe उसके denotion the way you write it I may call it g star in physics में you may call it something else but that's all there is we will look at all of this oh look at this Wheatstone bridge and all of that yeah यहाँ पे chemistry में भी आ गया Wheatstone bridge चलो let's get started this will be next session ठीक है मेरे सर के बिल्कुल पीछे I'll move it up don't worry कल के सेशन में we'll do this and we'll finish this up yeah molar conductivity and all of that all right let's get started right away how you doing hey Vishal hey Alex what's up Mission MBBS Ramji pranam how you doing let's go मैंने एक होमवर्क क्वेश्चन दिया था ठीक है I'm feeling homework करता नहीं है but that's okay we'll do it here anyway किया है क्या किसी ने होमवर्क I think no actually hold on I think कुछ लोगों ने आंसर क्लास के एंड में ही दिया था yeah some of you did that anyway we'll solve it here right now this is an important question if the electrolysis of aqueous NaCl in the electrolysis of aqueous NaCl 4 mole H2 are evolved along with 0.5 mole of oxygen और पूछ रहे हैं कि क्लोरीन कितना निकल रहा है this is interesting right because remember I ended the लास्ट सेशन के लास्ट पार्ट में प्रीवियस सेशन के लास्ट पार्ट में मैंने आपको बताया था कि कभी कभी पानी में कंपटीशन होता है एनोड में और कैथोड में कंपटीशन किस चीज का होता है जो एक्चुअल सपोजिड रिएक्शन है एंड हाइड्रोजन का एवोल्यूशन और एनोड पे क्या होता है जो जो रिएक्शन होना चाहिए उसके साथ ऑक्सीजन का एवोल्यूशन इन दोनों का कंपटीशन होता है बट यहाँ पे कुछ और चीज दी गई है ये आपको याद आ रहा है डू यू रिमेंबर दिस आई विल ओपन अप एनसीईआरटी वंस अगेन टू शो यू दिस पार्ट कहां पे था दिस इज एक्सट्रीमली इंपॉर्टेंट ओवर पोटेंशियल का आइडिया हमने यहाँ पे देखा था राइट लेट मी कंट्रोल एफ एंड लुक एट इट ओवर पोटेंशियल ओके कूल ओवर पोटेंशियल या लुक एट दिस यही चीज हम लोग इसी इलेक्ट्रोलिसिस की बात कर रहे हैं देखिए NaCl Na+Cl पानी में डालो निकल जाता है ठीक है कैथोड में क्या होता है हाइड्रोजन निकलता है एनोड में क्लोरीन निकलता है इन नॉट ऑक्सीजन इज व्हाट दिस इज सेइंग बिकॉज ऑक्सीजन का ऑल्दो ये इलेक्ट्रॉन द ई नॉट वैल्यू लोअर है बट काइनेटिकली धीरे है बट ये दिस इज थियोरेटिकल बट असलियत में क्या होता है कि थोड़ा थोड़ा ऑक्सीजन और ज्यादा क्लोरीन निकलता है दैट इज व्हाट दिस क्वेश्चन इज टॉकिंग अबाउट राइट इफ यू आर कंफ्यूज्ड अबाउट व्हाट्स हैपनिंग इन दिस क्वेश्चन यहाँ पे निकलना चाहिए क्लोरीन और थोड़ा सा ऑक्सीजन भी निकल जाता है और आपको पूछे चलो अगर इतना ऑक्सीजन निकला तो कितना क्लोरीन निकलेगा हाउ डू वी सॉल्व दिस क्वेश्चन मुश्किल लग रहा है क्या व्हाट डू यू थिंक हाउ डू वी स्टार्ट ऑन दिस क्वेश्चन ओके आई एम क्लियर दैट कैथोड पे कुछ अजीब नहीं हो रहा है कैथोड पे सिर्फ हाइड्रोजन निकल रहा है सो लेट्स राइट दैट डाउन राइट NaCl I have NaCl aqueous right पानी में मैंने डाल दिया तो aqueous हो गया and it gives immediately splits up into ions एनोड पे क्या हो रहा है कैथोड पे क्या हो रहा है वेल एनोड पे बिकॉज ओवर पोटेंशियल आइडिया हम लोग लिख रहे हैं कि दिस हैपेंस, ओके, व्हाई, बिकॉज ऑफ O2 का ओवर पोटेंशियल, राइट, जो मैंने आपको लास्ट क्लास में बताया था, ठीक है। कैथोड पे ये हो रहा है, बट इट इज ऑल्सो गिवन कि ये रिएक्शन भी हो रहा है, सो एट एनोड 1 and 2 आर बोथ हैपनिंग, ओके, which is interesting and it's possible, why not? मैंने बताया था कि मैंने ये नहीं बताया कि ऑक्सीजन नहीं निकलता है, जैसे ऑक्सीजन बहुत धीरे निकलता है। सी स्कूल के लेवल पे यू कैन से कि हाँ ऑक्सीजन नहीं निकलता है, क्लोरीन निकलता है, बट इन रियलिटी थोड़ा थोड़ा दोनों निकलता है। अब कहां से निकलेगा? एनोड पे निकलेगा, बट क्यों निकलेगा? बिकॉज ऑफ सम रिडक्शन हैपनिंग एट द कैथोड, जो इलेक्ट्रॉन्स वहां पे यूज अप हुए, यूज अप मतलब कि जहां पे देखो ये रिएक्शन 2 इलेक्ट्रॉन है ना, तो आएंगे कहां से? दो इलेक्ट्रॉन्स कम फ्रॉम द एनोड रिएक्शंस, ओके। So if we just figure out कितने electrons से कितने moles of electrons were being consumed not a right word, but कितने moles of electrons के साथ H2O react कर रहा था, उतने ही moles totally available होंगे from both the reactions of anode. समझ में आ रहा है? लिख के बताता हूँ, don't worry about it. What's up, Optimus Maximus? Really? We'll cure the aneurysm with some evangelism. Yeah, I don't want to get cancelled, but yeah, we'll try our best. So, कितना यहाँ पे निकल रहा है? You have 4 moles of hydrogen. Now, according to this reaction, यहाँ पे लिखा हुआ है 1 mole of hydrogen requires 2 moles of electrons. Okay, this is good, right? So I have 4 moles, so I would require 8 moles of electrons. ठीक है, 4 moles would require 8 mole of electrons. Okay, 8 मोल चाहिए, okay. उसमें से 2 मोल इलेक्ट्रॉन चले गए यहाँ पे. What do I mean by that? See, half a mole of O2 was formed. So let's put half over here. So then this becomes 1. Okay. Then this becomes 2. This becomes 2 as well. Okay. So half mole oxygen ke liye, I need 2 mole of electrons. And you see where I'm going with this? Ab to our job's done. 8 mole electrons were what were being consumed by water to give you hydrogen gas. उसमें से सिर्फ 2 मोल आ रहे हैं ऑक्सीजन से, तो बाकी कहां से आएंगे? बाकी आएंगे क्लोरीन से, ठीक है। लेट मी राइट दैट डाउन क्लियरली, ओके। तो मतलब 2 मोल क्लोरीन ऑक्सीजन ने फर्निश किए, क्लोरीन कितना करेगा? बाकी 6 मोल्स। सो क्लोरीन क्लोरीन टू फॉर्म क्लोरीन विल फर्निश 6 मोल ऑफ इलेक्ट्रॉन्स। हो गया। Using this I can get the mass of fluorine. Why? Because I know कि for 1 mole of fluorine I'll get 2 moles of electrons that are furnished. Okay. So अगर 6 मोल इलेक्ट्रॉन्स निकालने हैं मुझे क्लोरीन से, क्लोराइड से अगर मुझे 6 मोल इलेक्ट्रॉन निकालने हैं, तो आई नीड इनटू 3, राइट? आई विल फॉर्म 3 मोल्स ऑफ क्लोरीन, दैट्स इट। अब मास निकालना है, 3 मोल निकल गया, मास कितना होगा? 3 moles times 35.5? No, 3 moles times 71 gram per mole. Be careful. See, this is like the last line. यहाँ पे जाके please don't mess it up. Okay. Yeah. Chlorine का 1 mole is 35.5 grams times 2, which is 71 gram per mole. ठीक है, यहाँ पे आके गड़बड़ी मत करना प्लीज, दिस इज एक विनती है आपके लिए। So 3 into 71 should be 213 gram of chlorine that's liberated. Right? Exactly, Optimus. Hi, Sushi. Like the Japanese food. Hi, welcome. I don't think you've been here before. Welcome. Vishal bhai, did you figure this out? Alex, Ramji, and the guy giving random codes. Hacker, did you figure this out? Optimus, is this good? Electrolysis is fun, man. It's easy. Which part is hard, huh, Optimus? I've done the rest of it a little bit before. Which parts are hard for you? So this is how you figure out what is the mass of chlorine reacted, liberated. And interestingly, I gave you an example जहां पे over potential तो oxygen का था, but a realistic example where the ratio of this is like say what 1:6. Yeah, अगर 1 मोल ऑक्सीजन का निकल रहा है तो 6 मोल निकलेगा क्लोरीन का, yeah, mole wise. Mass ratio will be different, mole ratio इतना होगा. Interesting, right? So that's what happens in reality. When I say कि kinetically things are limited, मतलब कि थोड़ा बहुत ऑक्सीजन निकल जाएगा. It's not possible to control that. You can using some black magic stuff. Anyway, for how long does a current of 2 ampere have to be passed is an interesting question. एक और Optimus, one more question from electrochemistry, the last one for the day. How long does a current of 2 ampere have to be passed through a solution of AgNO3? What is happening here? So you have got Ag plus, that gives you Ag. That's the coating that's happening. To coat a metal surface of 80 centimeter square, 5 micrometers thick, density of silver दी हुई है. Okay. So surface area, I'm just telling you how to solve it. Okay. This is 80 centimeter square. Do you need that at all? We'll see. And this thickness that you see right over here, this thickness is 5 micrometer everywhere. Here, everywhere. Oh, so that way you get the volume of the coating. है ना? You get volume of the coating. ठीक है. From volume of the coating, you have density. So you do rho into V, you get mass. That's it. Then your job is done. Now उसके बाद क्या करना है? Then what do you do? M equal to Z I T. Do I have I have Z. What is Z? Z is 108 by 1 because n factor इसका 1 है into 96,500 into I into T is equal to mass. Khatam. Give me time. If anyone says 511, no, I'm gonna like, yeah, that's the time right now. Give me the time taken by this process to deposit this amount of silver. Yeah. Good to know, Nasimul. Good to know your test was good. But test अच्छा हो या बुरा हो, it doesn't matter. आप लोग try करते रहो, वही जरूरी चीज है. ठीक है? You gotta always keep trying your best. Got that one hair standing and that annoys me. And it just really stands up. Anyway, can't help it. I guess I need a haircut. How's this going? Sushi, are you able to follow this? Good evening. I think we already addressed that. Optimus, Alex, Vishal. See, I understand that I'm doing this on the NEET channel, and even on the JEE channel when I did this, people were like had switched off because they are generally, I've seen that people are scared of electrochemistry for some reason because you need to know a lot of things that come before it. But this is the part that's tested the most in JEE and in NEET, and it's really easy. Just you've got one equation, M equal to ZIT. That's all you need, and you need a little bit of redox reactions. And I think this is one part that one must never skip. ठीक से आराम से करने वाली चीज है. Should we go ahead and solve this one? Anyone trying it? कोई try कर रहा है? I'll tell you what we're going to do. Let's write down जो चीजें मैंने आपको यहाँ पे बोली एक एक करके. We'll just put them into one nice little easy thing so you can understand it. Here's a diagram, slightly better diagram. Well, I think the one I drew before was better, but anyway. Yeah. Area 80 centimeter square, 5 micrometer. Micrometer मतलब 10 power minus 6. Okay. But do we need meter, centimeter square? I think let's do it in centimeter, no? This is getting a little confusing. So let's do 5 into 10 power minus 4 centimeter times 80 centimeter square. ठीक है? So 5 8 is 40. So 400 into 10 power minus 4 centimeter cube. Cool? How much is that? Right? That's 0.04. Now let's keep it at that. What's the mass? 10.8 gram per centimeter cube times this. Okay. That is going to be equal to Z into I into T. You'll see how I haven't bothered really simplifying it further. I'm just leaving like this, hoping that something will get cancelled out. Ramji, बताइए तो. You're on a train, Optimus? Oh, all right, metro, cool. All right, see you, Ramji. So this is how you do this, right? As I said, you just have to figure out mass. This was the main step on questions like this. अगर कोई coating दी है, तो coating का पहले volume निकालो, multiply that with the density, you get the mass, and from there it's very direct, right? M equal to ZIT. Substitute. I've given you numbers, so that's easy to do. I've given you 10.8. There's 108 over here. You cancel this out. This goes once. This goes 10 times. It cancel हो जाता है. सब चीज आराम से nicely breaks apart. Well, not breaks apart. Breaks apart is bad. Cancels out. Cancels out. So looks like it should be 2 into 96.5. Yeah, 193 seconds is the answer to this question. Chalo, let's get started with the मुद्दे की बात. आज का जो main point है, which is conductivity of solutions. Now, what are conductors? Conductors are things that let electricity pass through them, right? Metallic conductor में charge carrier electron होते हैं. जैसे कि अगर मेरे पास एक cell है, I have a cell, right? Here I have electrodes, and outside this is a galvanic cell, which is why I have collector voltmeter, etc. Here maybe electrons are going out and coming in on this side. Matlab, this is the anode, this is the cathode, right, etc., etc. So bahar electrons जा रहे हैं. This is a wire. Maybe this could be a copper wire or aluminum wire, whatever. Yeah. So this is a metallic conductor. There are no chemical changes that are happening. Electron जा रहा है, but कोई reaction नहीं हो रहा है. ठीक है. But here at the surface of these electrodes, reactions happen. Okay. There's decomposition of electrolyte, oxidation, reduction, और वो सब चीजें हो रही है. और अंदर इसके अंदर make a solid will do all of that. इसके अंदर the charge carries the ions. Ooh, what kind of ions? We just saw, right? Cl minus giving you Cl2. ये एक रिएक्शन था, दूसरा कौन सा रिएक्शन था? तो क्लोरीन निकल, दूसरा हाइड्रोजन निकलने वाला क्या था? Here, you know the drill, right? This is an ion that physically moves around. Okay, it physically moves around a solution. That's the charge carrier. Okay, solution के अंदर मैं बात कर रहा हूँ. Now we're talking about say पानी. पानी में मैंने NaCl डाल दिया. हाँ. और फिर I pass electricity through. That is electrolysis. In that case, जो पानी के अंदर जो conductivity है, that is what we are trying to calculate. Yeah, it is conducting. Water is conducting. If you pass electricity through water, don't put your finger in it. You're probably going to get a shock. Not that much of a shock because these currents are very low, but don't do that. It's not a smart thing to do. खैर, यहाँ पे physically कुछ चीजें बन रही हैं and some things look like they get consumed. Okay, which is true. Like hydrogen gas is being formed. It looks like, oh, from the solution. Yeah. So solution का कुछ चीजों की concentration कम होती है, कुछ चीजों की concentration बदलती रहती है. Here, there's none of that on metallic conductor side. Yeah. And now the single most important thing आज की session में, resistance. Resistance is because of electrons they collide each other, and yeah, there's a lot of other particles there, right? And there are metal atoms as well, right? So इसकी वजह से resistance है. यहाँ पे resistance है because of ions, and ions are much larger than electrons, which means इसका resistance भी काफी ज्यादा होगा. I mean, I don't tell you that, right? An electron's tiny. I mean, what is the dimension of an electron? Great question. What's the dimension? It's really small, but anyway, significantly smaller. 10 power minus 15 meter. No, that's the proton. No, that's not a dimension of an electron. I was thinking of how do I give you a dimension of an electron? I don't think I have an answer to that right now. I'll think about it. But ions are large. I can give you the dimension of that. Ions would be of the order of, I don't know, like a few picometers, few hundred picometers maybe, or even a few hundred, because if I take one atom, right, that could be around 200 picometers or so, right? We saw हम लोग periodic table तो कर रहे थे. So an ion is significantly larger than that. An electron much smaller. So since ये बड़ा है, धीरे-धीरे move करेगा. Yeah, and also it's not moving through metal. It's moving through water and liquid, right? So it's going to move a lot slower. Hey, you remember this? When things move through solids, electrons especially, it's much faster as compared to liquid or through anything else, charges especially that. So the moral of the story is resistance काफी कम होता है जब solution में होता है. ठीक है, okay. And the last part, which is very important, it depends on the nature of electrolyte, which we will do in the next session. इसका क्या मतलब है अगले सेशन में लोग देखेंगे. ठीक है, strong or weak. Nature of solvent, viscosity, temperature. We'll look at these points today. This is all from NCERT itself. Okay. Here, definitely depends on nature of metal. ठीक है. Temperature, length, and area of cross section. Hey, you know this. R equal to rho L by A. Have you heard of this? R equal to rho L by A. Do you know this from current electricity? This is from school, right? 10th grade में पढ़ा होगा. Wait, 10th grade में पढ़ा था. Maybe this is not in 10th, but you know this, right? Resistance is because of some resistivity times L by A. So if I increase the length of the wire, resistance increases. If I increase the cross-sectional area of the wire, then resistance decreases. ये तो मुझे भी याद है फिजिक्स का, आपको तो जरूर याद होगा. Here we'll use the same equation, but we'll change things up a little bit. Same equation use करेंगे. अरे ना आप तो हैं, पढ़ना है कि टाइम पास करना है, आप बताओ. So the most interesting part here is that when you increase the temperature, conductivity, well, the conduction, let's just call it conductance. Conductance decreases. What is conductance? Conductance is inverse of resistance. It's as simple as that. What do I mean? So you've got R to be resistance, and what is conductance? 1 by R, which we will denote by the letter G, which is also an NCERT. Okay. But for electrolytic conductors, if you increase the temperature, this increases, which is pretty interesting. Pretty interesting. ठीक है. Why does this decrease? Because जब temperature बढ़ता है, if you have studied thermodynamics, partition of energy, equipartition of energy goes into translation. Temperature बढ़ाने से movement of particles increases, right? Translational, rotational, vibrational. Rotational come, but mainly vibrational and translation, right? Rotational तो बहुत high temperature की बात. खैर, because of this motion of particles, electrons whack into things more often, and hence resistance increases. But things are a little bit more complicated in electrolytic conductors. Yeah, I'm drawing parallels with physics right now for you. Resistance क्या चीज होती है? Physics से आप जानते हैं इसको. ठीक है? R equal to rho L by A. This is a metallic हम लोग वायर की बात कर रहे हैं. We will do this and then we'll quickly jump over to solutions. अगर कोई लेंथ है, क्रॉस सेक्शन एरिया है, directly proportional to length, inversely proportional to area resistance. Yeah, R equal to rho L by A, where rho is resistivity, which is a property of a material. I've already told you this. It is also known as specific resistance. Now, what we are going to talk about, because resistance is great and all, but हम लोग उसका उल्टे चीज की बात करना चाहते हैं, which is conductance itself. Before we do that, इस टर्म को हम लोग थोड़ा एक्सप्लोर करते हैं. ठीक है, हम लोग द सेल दैट वी टेक, मैंने बताया था ना, इसको हम लोग सेल बोल रहे थे, वेयर वी हैव an electrode over here, electrode over here. This was our depiction of a cell so far. है ना, ये हमारी सेल थी. Now let's look at another version of a cell. ठीक है, where I keep L and A constant. मतलब कि let's take a closed container now. We don't have to put a beaker and all that. Let's just take a closed container like this. ठीक है, इसकी fixed length है, और you'll see यहाँ पे एक वायर है, यहाँ पे एक वायर है, leads हैं that are going out to something else. इसके अंदर liquid बड़ा भरा हुआ है. There's liquid, okay, inside which there are ions. Okay, this has a fixed length and a fixed area. So this is now my conductance cell. We won't call it resistance cell. Let's just call it conductance cell. 1 by R is G. Okay, cool. ठीक है. This अगर हम उसको constant रखें, L by A को we call as G star, which is the cell constant. ठीक है. So rho is, remember, R equal to rho L by A. You're just going to have to remember this one equation. Remember this, everything else comes from this. So if you want to get things in terms of rho, you get R A by L. Okay. When L is equal to 1, area is equal to 1, then rho is equal to resistance. ये सब आप जानते हैं, you know all these things, yeah? These are things you know from physics. कोई बड़ी बात नहीं है. Okay, cool. So अगर मैं length of the wire को 1 सेंटीमीटर ले लूं, length of the cell को 1 सेंटीमीटर ले लूं, area of cross section को 1 सेंटीमीटर स्क्वायर ले लूं, area of cross section, लेंथ, ओके, इसकी बात कर रहे हैं, देन जितना रेजिस्टेंस की वैल्यू होगी दैट विल बी रेजिस्टिविटी. दिस इज जस्ट मैथ्स, नथिंग कॉम्प्लिकेटेड सो फार. ओके, नाउ इसकी यूनिट क्या होगी? व्हाट इज द यूनिट ऑफ रो? यूनिट ऑफ आर इज ओम, ऑब्वियसली. यूनिट ऑफ रो इज ओम इनटू मीटर और ओम इनटू सेंटीमीटर. दिस इज अ मोर रियलिस्टिक यूनिट, क्योंकि you do not have 1 meter long cells. You have छोटे छोटे cells, maybe 2-3 सेंटीमीटर. एक तो 1 मीटर की सेल नहीं होती है. ठीक है, so we will talk about things in terms of ohm centimeter. Okay, awesome. 1 ohm meter is 100 ohm centimeter. 1 ohm centimeter is 0.01 ohm meter. This is just because 100 centimeter equal to 1 meter. I know this seems like a maths and physics class. This is how it's going to be, at least for the next 15-20 minutes. ठीक है. Conductance क्या होता है? आपको बताया था, reverse of resistance, yeah, represented by G. Now we will write everything in terms of G. Now you see that G becomes A by L times rho. Why are we doing this? Because when you talk about this electrolytic cell, हमारा main focus है ये 1 by rho वाला term. We won't worry so much about this or this. These two things are okay, but main thing is this. Okay. कूल, ठीक है. अब इस चीज का यूनिट क्या होगी? व्हाट इज यूनिट ऑफ जी? जी की यूनिट नाउ बिकम्स मो. आई एम नॉट मेकिंग दिस अप. ओम, 1 by ohm is mo or Siemens. This is a company, you know, this is an electrical company, so it's either S or ohm inverse or mo. These are units of G. Okay, great. Okay, so what are the factors? What are the factors that affect this conductance solution? Okay, this is directly from NCERT. I'm going to show you where from, and then we'll continue this. Hold on, so that you guys don't think this is a bit too conductance. Let's go to that. Oh, look at that. We came to the right exact place where we wanted to. Okay, so we've covered all of these ideas right now, and look at the actual numbers that are given in the table. Just go through them. You don't have to mug them, but just have an idea about this. Yeah. So the conductance of the metal, yeah, is due to more electrons. We've done this: nature, structure of metal, number of valence electrons, temperature. Yeah, ये सब चीजें हैं. And right here, see, now we're talking about these points. This is what these slides are about. Okay, it depends on the nature of the electrolyte added, strong or weak, size of the ions produced, and their solvation. What is this? What is solvation? We'll talk about this. Li plus versus cesium plus. Solvation किसमें ज़्यादा होती है? You know this? You're in 12. You have to know this. Nature of solvent is viscosity. Viscosity मतलब, oh, if it's very gooey, it doesn't flow very easily, or it flows really easy. If it flows really easy, viscosity कम है. Okay. 6 pi eta Rg, you have done this in physics. Yeah, F is 6 by eta क्या बोलते थे? Eta like this, eta R, eta something G. I want to say R, but I don't remember this so well. So I'm not gonna write. But anyway, viscosity. Yeah, concentration of the electrolyte. Oh, this one's interesting. This is probably what we're going to focus the most on. And lastly, temperature. So let's go back to our slides and talk about these points in some detail. Okay, great. Just to prove to you कि NCERT में ये कुछ हम लोग नई चीज नहीं कर रहे हैं. ठीक है. Okay. Now between two ions, if there's any interaction, like देखो H plus बहुत छोटा सा है, very very small ion, it's probably going to move the fastest. It's going to have the highest conductance. Whereas something like SO4 2 minus, not so much. It's slightly big the ion. Yeah. So एक ion दूसरे के बीच में, not so much. So if there is some sort of force of attraction, which in case of H plus, there's going to be no force of attraction. It's literally just a proton. एक proton दूसरे proton को खेद करे, it'll just push it forward. Doesn't want to be close. When you look at this, एक सल्फर और दूसरे ऑक्सीजन के बीच में, like say like this, what is sulfate, right? 1 2 3 and 4, and there's another right here, right? Maybe there could be some sort of attraction between these two thingies. Yeah, maybe some sort of a, I don't know, hydrogen bonding or whatever. There is some electronic difference, some attraction is possible, right? So its resistance is not going to be that good. Yeah, its resistance is going to be, its conductance is not going to be that good. So if there's an interaction between the solute and the solvent, this is the hydration part I was talking about, that could affect things. अगर solvation ज़्यादा है तो resistance ज़्यादा होगा. Solvation का मतलब क्या है? Do you remember this from chemical bonding? We said that how do we decide if something is dissolved easily or not? By two things. One is एक था lattice energy. Yeah. So I have to break stuff from its lattice. If something NaCl exists as solid, पहले उसको तोड़ना है. उसके बाद उसको solvate करना है. किसको solvate करना है? इसको और इसको. I have to solvate both of these ions. Solvation मतलब पानी. Yeah. Each of these ions are going to be surrounded by a lot of water molecules. Right? Do you remember this from bonding? Yeah. So if the solvation energy is very high, it usually is for very small molecules, then the resistance is going to be high. Because look, what do I want for a resistance to be low? The ion should be able to move freely. अगर ion बहुत बड़ा हो गया है, इसमें बहुत ढेर सारे पानी के molecules आसपास आ गए हैं जो चार्ज को इतना accessible नहीं कर रहे हैं, that's not good, right? So अगर solvation ज्यादा है and charge भी ज्यादा है और size, it's not good, right? Solvation अगर ज्यादा हो गया तो size भी ज्यादा हो जाएगा. So Li plus, this is the hydrated and the largest one, and cesium is the smallest. So resistance of Li is going to be a lot more than that of cesium. Is this part okay? It's pretty important. Although it's not been tested a lot in NEET or JEE, but who knows, it could come. Because this, as I said, is directly from NCERT. I'm going to show you NCERT for एक बार. You see this? This idea of size of ions produced and solvation. So questions could be asked on this. Do you understand this? Is this okay? Please let me know in the comments if this is fine. Give me a thumbs up if this is okay. Yeah? We good? So, the next idea is, so we've done solute-solute interactions, solute-solvent interactions, and solvent-solvent interaction itself. मतलब कि क्या? Why would a solvent want to interact with itself? Well, viscosity, right? If something is high viscosity, तब उसमें ions flow करने के लिए उसको मुश्किल होगी. So viscosity is high, then clearly the resistance will be high. The reason I'm talking about resistance, not conductance, because resistance is something you're more familiar with. We'll switch to conductance very soon. ठीक है? This is it about that. अगर temperature बढ़ता है तो resistance कम होता है. ठीक है? But this also depends on whether your setup has a strong or a weak electrolyte. Okay, a strong electrolyte would have high conductance, not resistance. Now we're talking about conductance. We'll switch gears. I told you we'll switch to conductance, and we've done that right now. If you've got a weak electrolyte, that's low conductance. A strong electrolyte has high conductance. Okay, cool. So अभी तक हम लोग बात कर रहे थे conductance and resistance में, and I told you that my focus throughout is going to be on 1 by rho, which is known as conductivity. What is conductivity? Well, it's the reverse of resistivity. It's as simple as that. It is also called specific conductance. Now, these things get confusing. But I think if you draw parallels with physics, it becomes easy. क्यों? क्योंकि physics में resistance क्या था? R. And resistivity क्या था? rho, which is, you know, R equal to rho L by A, etc. etc. Okay. Also, इसको हम लोग specific resistance भी बोलते थे. किस चीज को? Rho को. Similarly, I'm asking you to treat conductivity to be 1 by resistivity, also known as specific conductance, like specific resistance. अंग्रेजी के थोड़े शब्द हैं, 2-3 बार लिखिए, आपको समझ में आ जाएगा. ठीक है? Don't feel that this is very complicated. All right, cool. So let's talk in terms of conductance and conductivity. R was rho L by A. So G, which is equal to 1 by R, is going to be equal to kappa, which is equal to 1 by rho times A by L. Right? And remember, I will keep L by A as G star, which is cell constant. ठीक है? वो हम लोग को ऐसे ही as it is रखेंगे. Cool. So kappa is going to be equal to G L by A. Is that right? Is that right? Kappa is equal to G L by A. Perfect. Which is also going to be equal to G into G star. Easy enough to remember, right? GG. Yeah. Gamers in the house. What is the unit of this? What is the unit of conductivity? Conductance की unit थी mho या फिर MOH, no MHO. R was ohm, G was mho or ohm inverse or Siemens, right? What about kappa? Okay, इसकी unit क्या होगी? Unit is going to be simply Siemens per centimeter or ohm inverse per centimeter or mho per centimeter. I'm going to focus on these units as I told you because हम लोग जो चीजें लेंगे, the equipment we're going to use in lab are going to be small things. We don't need per meter units. Per centimeter units are more useful to us, easier to understand. And you can convert between this unit to this unit easily. कभी कभी JEE advanced में यही हो गया था कि instead of giving you centimeter units, they give you meter units. So that way you just have to be careful कि आप कर क्या रहे हो. So don't do things blindly. It's important you do things from first principle in this chapter, especially ये वाला part. And this is tested time and again, man. Whether it's JEE main, advanced, NEET, कहीं पे भी हो, this is asked again and again and again questions on this. So please do this properly. Sometimes, if you want to talk about things in terms of volume, you could also write this. It may not always be necessary to do that, but this is basically saying, okay, similar to that. Remember, if I take a cell that has a volume of 1 centimeter cube, length of 1 centimeter, then kappa is equal to G, just like what we did resistance and resistivity. All right, cool. Let's move on from here. This is not that crazy important. All right, how do I measure this conductivity of ionic solutions? कैसे करूंगा measure? Let's take a cell. Yeah, जैसे cell मैंने दिखाया था आपको, वही L by A उसको लेते हैं हम लोग, ठीक है? So we'll find out the conductivity using this resistance of the electrolyte and the cell constant. Resistance कैसे measure करेंगे? Wheatstone bridge. The best way to measure resistance is Wheatstone bridge. Okay, and you have seen this in the NCERT as well. I'm going to quickly open up the page over here where this is there, so that again you know that what we are doing is exactly in NCERT itself. Yeah, measurement of conductivity ionic solutions. You got to do all of these things right here. Okay, you've got a detector in the middle, so you've got to balance out the other resistances so that no current passes through this. Yeah, that's the general idea of this. So that way you get acha theek hai. That's only going to happen if you'll get the value of R2 given you know that all of these three resistors, you know that resistance. That's the concept of a Wheatstone bridge, right? A variable resistance, etc., etc. So this statement over here in NCERT talks about this in detail. Please read this in some detail. Okay, yeah. And remember, I think all you're doing here is you have resistors in parallel, right? That's all this is. Khair, let's get back to our session. One second. Okay, cool. So using the value of G star, what is G star? It is L by A, which is cell constant, and R of the solution, conductivity of the cell is figured out. So kappa is G star by R or G star into G. मैं बार-बार equation लिख रहा हूं ताकि आपको याद आ जाए ठीक से. Now we'll go over a couple of properties of conductance. Okay, one is that conductance is extensive, conductivity is intensive. Extensive, intensive, मतलब if I take a lot of something, right? If I increase the quantity of something and uski value badal rahi hai, the property is changing, then that property is extensive. By changing the quantity of stuff, if that property does not change, then it's intensive. This is an easy way to remember it in this case. There are many definitions to intensive and extensive. This definition makes sense over here. मतलब कि resistance या conductance बढ़ेगा if I take more of the solution. But conductivity is not going to change if I take 1 liter or 10 liter. उसका conductivity same रहेगा. Conductance may change. ठीक है? Cool. That's what I mean by extensive and intensive property. But this kappa value depends on the number of ions in the solution, which means it depends on the concentration of the electrolyte. ठीक है? It depends on that. इसको हम लोग थोड़ा एक्सप्लोर करेंगे अगले सेशन में. कॉन्सेंट्रेशन से क्या पलरा पड़ता है, व्हाट इज द पॉइंट ऑफ दिस. ऑल्सो अगर मैं सेम टाइप की सेल लूं, लेट्स से आई हैव 4 or 3 or 2 cells that have the same L by A value. ठीक है? In that case, if I connect those cells in parallel, what happens to the resistances? What do you think? What do you think? But resistance, तो आपको you have to do this, no? 1 by R effective is equal to 1 by R1 plus 1 by R2 plus 1 by R3, etc. Which means I can add up their G values, which means I can add up their kappa values. Right? That is pretty cool. So, what we do is to measure these conductivity values. We can have multiple different cells and you can add up the kappa values if and only if L by A is constant and you're connecting all of them in parallel. ठीक है? Is this okay? I feel like I'm doing a little bit of physics and हो सकता है कुछ चीजें आपके सर के ऊपर जा रही हैं. And this is why this may be considered to be a little bit complicated by some people. But I feel that this is very doable. कोई बहुत complicated चीज नहीं है. It just requires you to read up a little bit. ठीक है? This part specifically may not be there in NCERT. Let's look. Let's देखते हैं हम लोग देखते हैं कि क्या ये पॉइंट, ये बारीकी NCERT में है कि. Let's just go look up the word parallel. I have a feeling it's not there. If it's there, that's amazing. But we'll just look it up anyway. Yeah, it's not there. I thought so. नहीं है ये चीज. ठीक है? ये छोटी छोटी बारीकी वाली चीजें they help you understand concepts better. ठीक है? I hope this made sense to you. Let's take a quick question. Conductance with units Siemens is directly proportional to the area of the electrode plates and the concentration of the solution in the cell and is inversely proportional to separation between electrode plates. What is the unit of constant of proportionality? Hi? ये सवाल करके बताओ. What do you think? Conductance with unit Siemens is directly proportional to the area of the electrode plates and the concentration of the solution in the cell and is inversely proportional to the separation between the electrode plates. एक electrode, दूसरा electrode. This is that same cell we were talking about, right? This is the area of the cell. Yeah, this is the area. This is the length. This is electrode 1. This is electrode 2. ठीक है? और ये L है. तो they are saying it's also proportional to concentration. अभी तक हम लोगों ने concentration की बात नहीं की थी. ठीक है? So, if I say that G is equal to A into C by L into some constant, तो इस constant की unit क्या होगी? That's what's been asked. Can you do this now? Please try this. Please try this. Take a minute. It's okay. Very doable. So the main thing here you've got to do is dimensional analysis because बाकी सब तो मैंने आपको चीजें already दे दी हैं, right? अच्छा, एक और इंटरेस्टिंग चीज है यहाँ पे मीटर में दिया हुआ है समथिंग मे बी सेंटीमीटर क्यूब, राइट? ओके, we'll figure it out. कर लेंगे आप लोग. How do we do this? G का यूनिट है, यही चीज मैं लिखी है. A is area, C is concentration, 1 by separation is 1 by L. So what are the units over here? Yeah, area is going to be ml2 mlt, right? So L square is area. This is going to be mole divided by L cube. L is length. मैं dimensional axis की बात कर रहा हूँ, ठीक है? And this is going to be 1 by L. Oh, so if you multiply all of these things together, L square into mole by L cube into this thing, what do I get? I think I figured out what to do from here. It's very doable, right? Let me erase this because यहाँ पे चीजें लिख के आ रही हैं. G will simply be equal to the unit. Siemens will be equal to liter square by liter cube times mole plus into K over here. This is my constant. इस कांस्टेंट की ही हम लोग को यूनिट निकालनी है. So clearly Siemens is going to be there into say liter square per mole, not liter, into L square. What is L? L is, let's say, meter square, right? L square is going to be meter square. So I think this should be the answer. What do you think? Or is it something else? Did we mess something up? Oh, yeah, it's L4. I think that's what. I think that works. Finally, power aa gayi. All this while we were running on, yeah, fumes. So this is the unit of this constant, which is Siemens. L, this L here, by the way, is from dimensional analysis. Okay, do not get freaked out as to what this is. Dimensional analysis wala L hai. ठीक है? So the answer is Siemens meter square per mole. And we look at this, by the way, this is something that we'll look at in the next session. What is this? This thing is called lambda. ठीक है? Lambda is molar conductivity. We'll look at that in the next session. Anyway. This is quite interesting, isn't it? This is the answer to this question. Next one. Resistance of 0.1 molar KCl solution in a conductance cell is some value and conductivity is another value. What is the value of cell constant over here? Ooh, cell constant. कैसे करें इसको? How do we do this? Cell constant is G star, which is L by A, right? Resistance आपको दिया हुआ है. Resistance मतलब 1 by G, okay. 1 by conductance, okay. Conductivity दी हुई है. Kappa was G into G star. This is what I remember, and I will use this, right? Okay, great. So I basically have to just substitute this, है ना? I have to do 1 by 300 into G star, which is L by A, into G star is equal to 0.013. This is what I would do. I don't think I need anything else. I don't think I need this. I do not need this. What do you think? If you want, you can pause the video and check this out here. I don't think I need that. We'll see. Let's see. Let's write this down. Erase all link on slide. I don't think I need that. आपको क्या लगता है? अर्णव भाई हो या भाग गए? हाँ. So as I said, kappa is simply G into G star. You can write down many different ways of doing this. So G star is simply kappa into R, which is this into 300, which happens to be 3.9 per centimeter. Does it make sense? Does this unit make sense? Remember, G star was L by A. So it needs to have the unit or dimension basically of L inverse. Not unit, but the dimension should be L inverse. And this makes sense. Centimeter inverse makes sense. Why centimeter inverse? Because everything here is in terms of centimeter. This does not matter. इसकी जरूरत नहीं है. Ohm है यहाँ पे. So it's not meter. Meter की बात ही नहीं हो रही है. The only option है centimeter inverse is this. So you can just blindly mark that. Awesome. Great. Cool. That was it that I had planned for you today. I've got another homework question for you as always. Here it is. Please try this out. And we'll talk about it tomorrow in some detail. Okay. The electrical resistance of a column of 0.05 mole per liter NaOH solution of diameter 1 centimeter and 50 centimeter is some value. Calculate the resistivity and conductivity. Excuse me. Very direct. And again, I don't know if you need this. Do you need this? Think about it. Okay. This is the homework question I'd like you to try out. If you try it out, you can ping me on iTeachChem on either Telegram or Discord and give me the answer, or we'll also discuss it tomorrow. Okay. Thank you everybody for your time. That's it for now. Let's quickly look at NCERT and what we did so far. Not this. This is something that I want you to study by yourself. Conductance. All right, sweet. So we did all of this. Yeah, yes, हमने किया. These values just read it to get an idea of what the values are like. Yeah? Interestingly, in this question, in your book, all values have been given in Siemens per meter, but most questions you see will be Siemens per centimeter. Okay. We've done all of these ideas. We've done this. We've also covered this, and we are going to do this. This is where we're going to start in the next session. That's going to be tomorrow at 5 p.m. Okay. So please, this topic, this whole chapter has a lot of NCERT questions, but no, it doesn't. It has only 18 questions. You're lucky. It has only 18 questions. Okay. If you're preparing for JEE, you should also do the exemplar questions. Let's look at कितने सवाल हैं exemplar पे. Electrochemistry exemplar. Do you even know what exemplar is? Wow, this looks really scary, but that's the right one. I'm not even kidding. This is the exemplar. If you don't know what exemplar is, it's a good time to open it up if you've finished the chapter. Yeah. और इसको भी please solve करिए. Wrong thing. इसको करना था बड़ा. All right, cool. Yeah. Look at that. It's got a lot of questions. I hope. Yeah, significantly more. ये उसमें 18 थे, इसमें है 50, 60, 60, 55. Oh, this has significantly more. 66, 68, 68 questions in this. आप लोग चाहते थे practice इसमें 68 questions है, उसमें 18 questions है. Do these, please do these, and you're sorted. This is all you need to do for JEE Main or NEET. I'm not even kidding, right? Yeah, that's the plan for today. And tomorrow I'm going to be live at 8:30 p.m. We're going to do some awesome questions on mole concepts. So come check out, get that on the JEE channel. On the NEET channel at 5, I'll finish off electrochemistry as usual. Cool. चलिए मिलते हैं कल. See you. Bye. नहीं, कल सैटरडे, हाँ कल मिलते हैं. 5 o'clock tomorrow we'll continue this and 8:30 we'll do more concept. Tata. See you.